Internal resistance of a cell. Circuit diagram. Materials required: ammeter, one-way key, rheostat, battery, potentiometer, resistance box, Lagrange cell, one-way key, high resistance box, and galvanometer. Procedure. Connections are made as seen in the circuit diagram using the connecting wires. Insert the one-way key K1. Adjust the rheostat and note the ammeter reading. To check whether the connections are correct or not, place the jockey at the two end points of the wire. If the galvanometer shows opposite deflections, the connections are correct. Without inserting the key K2, slide the jockey over the potentiometer wire and stop when the galvanometer shows zero deflection. Measure the length from point P. It is taken as the balancing length L1. Record the value in a tabular column. Now introduce a low resistance of 0.2 ohm on the resistance box. Insert the one-way key K2. Again, slide the jockey over the potentiometer wire and measure the balancing length L2. Record the value in a tabular column and calculate the value of internal resistance R. Introduce a low resistance of 0.5 ohm. The key K2 is inserted into the switch. Slide the jockey over the potentiometer wire and measure the balancing length L2. Record the value in a tabular column and calculate the value of internal resistance. Introduce a low resistance of 1 ohm. Slide the jockey over the potentiometer wire and measure the balancing length L2. Record the value in a tabular column and calculate the value of internal resistance. Repeat the experiment by reducing the value of R low resistance successively, and each time measure the balancing length and calculate the mean value of internal resistance. From the experiment, it is found that the internal resistance of a cell increases with external resistance, and the average value of internal resistance of the given primary cell is 2.502